Asymmetric VR is an emerging solution for a relatively new problem. Virtual reality is viewed as isolating in part because it is marketed as a single-player technology. While asymmetric VR solves this by giving spectators a way to interact with, or at least see into, the virtual space, there's no driving theory or unified conceptual framework to guide creators or researchers. To help close this gap, we gathered and filtered 200 papers to reveal the theories which have, to date, guided academic work in the area. This paper, a composite framework of co-located asymmetric virtual reality, describes the scope of the 18 theories and proposes CAVR, the composite framework for asymmetric VR. An asymmetric VR experience is one in which one person interacts in at least the virtual space using a headset, while the other or others interact with the virtual reality user in one or more spaces by way of another modality, such as a phone, a video game controller, or even just a simple piece of paper. In a popular game, Keep Talking and Nobody Explodes, the virtual space is experienced by one person through a head-mounted display. They see a bomb with various features that they must describe to people in the physical space who have access to the manual, which can be used to defuse the bomb before the time runs out. The shared space in this example is absent, and that is, in fact, part of the fun. I'll talk a little bit more about this later. Asymmetric VR is a popular method of bridging the social interaction gap of virtual reality headsets. Keep Talking and Nobody Explodes is just one example of asymmetric VR, and it was created as part of a game jam. Most such games have similar origins, coming from independent developers with low budgets. As of now, few, if any, well-known game studios have asymmetric VR releases. And while it seems ripe for use in hub and satellite teams, in therapy, and as gateways into more equitable virtual reality experiences, non-game asymmetric VR applications are also quite sparse. To support VR creators in kind of getting into this space, we used a scoping review to identify papers published on virtual reality use in co-located groups. By that, we mean we searched Scopus looking for papers that had some sort of a reference to a virtual reality term and either a collaboration or a co-location term. We screened those papers and identified additional ones through the snowball method. And from that pool of 200 papers, we looked for the underlying theories that were within those identified papers. We ended up extracting 18 different theory papers from a variety of different fields, including CSCW through studies of groupware and media spaces, extended reality, decision-making, both for groups and from economics, team dynamics by way of organizational psychology, and other tech frameworks from areas such as CSCW, again, education technology, and modality, or the study of video games. Asymmetric VR occurs across both virtual and physical space and is impacted by both technological and sociological factors. By comparing existing theories of asymmetry from media spaces and game mechanics, and by incorporating relevant theories from other identified theory papers, we ended up with 5 dimensions: transportation, spatial copresence, informational richness, balance of power, and team interdependence. Transportation describes the degree to which the technology facilitates access to the affordances of the physical and virtual spaces plus the shared space. As I mentioned before, in Keep Talking and Nobody Explodes, there isn't really a shared space. The game is about overcoming the lack of shared space, so to speak. The next dimension, spatial co-presence, is influenced by design decisions around mediating interactants' access to one another in the shared space. Spatial co-presence is experienced as togetherness in the mixed reality space. In Keep Talking and Nobody Explodes, there is a sense of togetherness, but it's through the creation of a shared narrative. There isn't really a shared space, so to speak, but you're working with somebody to solve a problem that seems real enough. The extent to which technology delivers and captures information about the shared space, or informational richness, is pivotal to communication effectiveness within a team. It's dependent on quality of information rather than quantity. In Keep Talking and Nobody Explodes, this is actually one of the sources of fun. Again, it's sort of accentuating the limitations of asymmetric VR, or of virtual reality that isn't mediated, and showing, creating a fun and engaging game that actually works with this lean communication experience. Mutual access to physical, virtual, and shared spaces affects the balance of power in a group, meaning members' access of and control of information. Beyond just the interface that is given to them, both input and output, this is impacted by the roles that are designed for a specific technology and the experience of the people who are using it. In Keep Talking and Nobody Explodes, the more experience that you have, the easier it becomes, because you find ways to communicate the visual experiences in ways that make sense to the people that you're playing with. In other games, there are different balances of power, and they have to do with the decisions of the designers again. Team interdependence arises in groups whose members must rely on one another to accomplish their shared objective. Group members bring different goals and backgrounds to what they're doing, and we see this in games as well as outside of games. In Keep Talking and Nobody Explodes, it requires a lot of team interdependence, because one role has access to the visual information about the bomb, and one group or one role has access to the information about how to defuse the bomb. Given that visual information, they have to work together in order to accomplish the shared objective, even though they might have different goals that they must reach before they can get there. The next step is to evaluate existing asymmetric VR games, such as this title, Babies and Basilisks, in which the virtual reality player creates a dungeon using different building block pieces and actually puppeteers the different enemies that the four PC players have to battle against. This creates a dungeon crawling experience for people who are outside of the game while still involving the virtual reality player. Asymmetric VR facilitates coordinated action in games and has broad potential applications for outside of entertainment. By understanding how and why these games and others support coordinated action, we can help future creators make experiences which work with the differences in people and in tasks to optimize the collaboration potential of teams that are using the technology, both in games and beyond.